Welcome back. This is domain number 3, securing your infrastructure. To handle this domain, you need to be comfortable designing edge security, content that's outside of the region itself, being able to design and implement the secure network infrastructure needed, as well as troubleshooting the network infrastructure, and finally, whatever host-based security you're going to need as part of the overall picture. This is the biggest domain out of all of them, coming in at 26% of the total exam. Let's dive in. Taking a look at edge security. There's a number of key tools you need to be comfortable with. As we talk about being out on those edge locations, Route 53 DNS is important, as well as the AWS WAF, the Web Application Firewall, CloudFront, and AWS Shield are also in play. You need to understand how Route 53 plays out in your certification, so make sure you're comfortable with the basic feature set. Route 53, highly available out of the box. It's the only product from AWS with a 100% SLA. Make sure you understand how it works with other AWS services, especially how it takes care of being flexible and secure in your application. Know how to use AWS WAF, how it's going to actually provide you protection from external web attacks, from DDoS attacks, SQL injection attacks, how to actually manage security through AWS WAF with all the various services that can integrate with it. AWS WAF provides improved web traffic visibility as well as enhanced security with managed rule sets you can decide on. There are a variety of conditions you can put into play as you set up and actually control what traffic to allow through the WAF. You can set them as needed to control specifically what you want to deny and what you want to allow into your system. Amazon CloudFront, CDN as a service. It runs at all of the edge locations around the world, handling security at the edge. One of the great things there is if you can manage security out in those edge locations, then no bad requests ever actually get into the region itself. Effectively, you'd have to DDoS the entire internet if you want to take down CloudFront. Very programmable, lots of options are available for you, and of course it's integrated with many AWS services and can even be integrated with on-premises solutions. AWS Shield is available for customers at no additional cost. AWS Shield Advanced gives you additional security choices, including protection for the most sophisticated DDoS attacks. As we look at the global spread of AWS, it's important to know we have our regional locations, that's the large dots on the screen, and those regional locations also have edge locations as well. So even though your data might be located in Singapore, you might be using edge locations in Ireland and Sydney and Sao Paulo and wherever else in the world there are regions. Of course, the smaller dots are edge locations, and the purple dots, as opposed to the blue dots, have many edge locations close to each other. The map simply doesn't have enough resolution to show all the individual pieces. We talked about DDoS mitigation in terms of Shield. There are many other tools that can be used to help protect you against DDoS attacks, including the Elastic Load Balancer, CloudWatch, Autoscaling, and Shield. Route 53, WAF, and CloudFront also play parts. Let's talk about how to actually design and implement your secure network infrastructure. Now, there's a lot of moving pieces when we talk about network infrastructure, beginning with the VPC itself. The VPC designed to isolate all traffic from your network from the millions of other customers all running inside AWS. You don't want them inside your secure traffic, and they don't want you inside theirs. The VPC completely isolates your traffic from anyone else unless you have explicit permission from those packets to cross the boundaries. The various gateways, make sure you're familiar with those, the internet gateways, the virtual private gateways, the peering connections, all those are the only way traffic goes in or out of the VPC. Understand the network access control lists, security groups, and where they play. The network ACLs at the subnet level, security groups at the instance level, Also understand NAT gateways and ways to communicate from private subnets, also out to the public internet by going over the NAT gateway itself. I want to dive a little bit deeper into the concept of network ACLs compared to security groups. Make sure you're very comfortable with those differences. The idea that network ACLs are stateless, they are managed at the subnet level. Rule sets with network ACLs are sequence-based. The first one to get a hit, that's the rule that matches. In this case, I've got inbound rules to allow SSH traffic if it's coming from a single specific IP address. In this case, 172.31.1.2. If I'm coming from that IP, I'll allow SSH traffic. Any other port, protocol, or IP address will then fall down to the next rule, which simply is a flat-out deny. It's also important to know that because it's stateless, there are specific inbound and outbound rules, and simply because traffic was allowed in does not mean it's allowed out. In this case, I've simply duplicated my rule set. So same rules in, same rules out, but they don't have to match. Looking at security groups, this is stateful. You notice I'm allowing SSH traffic, again, for that same IP address, 172.31.1.2, but I don't have to set an outbound rule to allow the return traffic to go back. If I allowed it in, I'm going ahead and allow the return traffic because of the stateful nature. Also, there are no deny rules in a security group. If you want to block traffic, you have to do that in the network ACL. Security groups are my allow process. Now, the nice thing with security groups is I don't have to only identify IP blocks. I can identify source security groups as an additional way to mark where traffic is coming from. In this case, I've allowed communication from anything inside the My Security group to be initiated or allowed inbound or outbound. That way, anything inside this cluster can communicate to each other without any blocks. Next topic, designing and implement host-based security. So this is dealing with security from the operating system on up. First place we look is the Amazon machine image itself, because this is where we actually install the root volume template, as well as any launch permissions that might be involved, block device mapping. This is where you get to set up those configuration elements. Now, there's additional security considerations you need to be aware of when you talk about AMI, and that is to make sure that the AMI only delivers what you want. Don't have it have every single service that can be installed if you're not using it. Take the time to disable services you don't need, protocols that might use clear text. Get yourself down to just the key pieces you want. Disable any non-essential network services or any default services like print spoolers or RPC if you don't actually need them. Do not install any credentials on a baked AMI. Delete any third-party credentials from any disk. That way people can't use it and use your licenses. Certainly delete any user SSH public and private key pairs as part of your AMI and passwords that might otherwise be installed. Finally, clear any system and event logs before baking the AMI.